The topic is to upgrade the software of a device like a GPS Garmin in order to make it able to provide information to the runner on how much margin he has got at a certain stage of the run to continue the workout before reaching his or her breakdown point. This can be achieved either online, during the run assuming to be the owner of the device, or offline, extracting the raw data and generating at each step the resilience function. Here we assume to modify the GPS Garmin equivalent software for runtime resilience function availability. This opportunity is an attractive use case for a machine learning-based solution for the availability of big amount of data that allow to make prediction. I'm considering a problem that runner has when wants to improve its performance in a scientific way. This is the target user. The problem is to provide a resilience indicator to the runner that is using a device equivalent to this GPS Garmin with a heart rate monitoring band. The resilience function is here interpreted as the margin that the runner has to perform effort at a certain point of the workout, given the current physiological state that he has achieved during a run, considering the data provided by the GPS Garmin equivalent device. This problem matters because resolving it would allow the runner to be aware of its state in a specific situation and manage the upcoming part of the training, avoiding to fall in an unproductive condition, being able to reduce the intensity of the run of the optimal quantity and increase the final total work at the end of the session. Today, this problem is solved, at least with the not most recent devices, providing information of metabolic zones from zone 1 to zone 5 that allow to understand the metabolic regime among aerobic and anabolic with lactic acid, anabolic without lactic acid, that permit to the runner to estimate for how long he or she can sustain a certain effort. The gaps stay in the fact that the lack of prediction of the margin that the runner has to continue to train till its maximum capacity. The expected business impact is that the product will be more competitive than that of the competitors. The constraints are that this capability must be available during the run for 3 different workout categories that can be selected by the runner. Long run, assuming to remain in aerobic zone 2 and zone 3 regimes. Threshold tempo run for zone 3 and zone 4 regime. Interval training for zone 4 and 5 regime. The expected business impact is to improve the outcome, increasing the revenues, for example, by at least 15%. The expected technical output metrics is split according to the workout category described above. Category A, assuming that the runner is performing a long run training, the resilience indicator shall be able to predict with an error, for example, less than 30%, the minimum number of minutes that the run can sustain at the same pace, before it feels the red flag sensation that it is too tired to continue and it needs to stop. Case B, assuming that the runner is performing a threshold run at a fixed speed, the resilience indicator shall be able to predict with an error, for example, less than 20%, the minutes he can sustain the run at the same pace before he feels the red flag sensation that it is too tired to continue and it needs to stop. Case C, assuming that the runner is performing interval training at a defined fixed speed for a defined amount of time with a defined recovery time among repetitions, the indicator shall be able to predict the number of repetitions the runner can sustain until it feels the red flag sensation that it is too tired to continue and it needs to stop. The resilience indicator shall be able to predict with an error, for example, less than 20% the number of repetitions that the runner can sustain in such condition. Now we explore the potentially relevant factors in this work. The domain expertise is here in the field of physiology, and an understanding of the 3 metabolic processes involved in the run is needed to be able to make predictions. In case A, the long run, the key aspect is to evaluate if the heart rate goes above the low zone 3. So the heart rate is a key factor to be used to make predictions. Data from previous long run performed with the same logic to feel till the red flag sensation provide a key aspect to know if the muscular status is fit to support the mechanical stress, and that is the second key factor beyond heart rate. In case B, the threshold run, the key aspect is the heart rate. In particular, there are heart zones, then also the aerobic and anaerobic thresholds that are not part of raw data, but it is assumed that they have to be known with any methods. This data, together with the data of previous tempo run, perform the same logic to go to the reference station, provide a key aspect to know if the muscular status is fit to support the mechanical stress, and that is another key factor beyond the factor mentioned above. In case C, the key aspects are the speed, the time, the recovery time, and the data of previous run for the interval training to provide info to know if the muscular status is fit to support the mechanical stress. The validation plan consists of working with at least 3 athletes of different characteristics in terms of age, gender, and training level, and compare the predicted versus actual performances for each of them for a certain amount of workouts. The validation is assumed to be performed with the different metrics according to 3 running categories illustrated before. The machine learning system design decisions are edge, as this is an embedded system, offline learning, easy to implement for retraining that can be done periodically after execution of a set of additional workouts, online predictions, as it is required to provide the status during the run. Potential risks may arise in production due to data drift caused, for example, by changes in environment like season of the year or weather-related aspects impacting the performance, or by concept drift due to the fact that the runner used for training may be not fully representative, and widening with more athletes may lead to a different pattern.